AI never sleeps, and now it can enhance video in real time. Stream-DiffVSR introduces a new way to enhance video quality in real time using artificial intelligence. Video super resolution has improved dramatically in recent years, especially with diffusion models. These methods can generate sharp, detailed frames that look far better than traditional upscaling techniques. The problem is speed. Most diffusion-based video enhancement systems are too slow for live or streaming use. They rely on future frames to maintain consistency, and they require many denoising steps to reach high quality. This makes them impractical for real-time applications. Stream-DiffVSR is designed to solve this exact problem. Instead of waiting for future frames, Stream-DiffVSR processes video using only past information. This makes it a truly online and streamable video super resolution system. At the core of the method is a causally conditioned diffusion framework. Each video frame is enhanced based on previously processed frames, allowing the model to maintain temporal consistency without introducing delay. This causal design is the key breakthrough. It allows diffusion models to operate in real time rather than offline. To achieve high speed, Stream-DiffVSR uses a distilled denoising process. Instead of dozens of diffusion steps, the system performs enhancement in just 4 steps. This dramatically reduces inference time while preserving visual quality. The model also includes an autoregressive temporal guidance mechanism. This component injects motion-aware cues from earlier frames, helping the system understand how objects move across time. As a result, details remain stable instead of flickering from frame to frame. A lightweight temporal-aware decoder further refines the output. It enhances fine textures while keeping motion smooth and natural. This balance between detail and consistency is critical for video quality. Together, these components allow Stream-DiffVSR to achieve low latency while maintaining strong perceptual results. In practice, the system can process high-resolution video efficiently, making it suitable for real-world scenarios such as live streaming, video conferencing, and online media enhancement. This research demonstrates that AI models are no longer limited to slow offline tasks. With the right architectural design, they can be adapted for real-time video processing. Stream-DiffVSR represents an important step toward practical, high-quality, real-time AI video enhancement. It shows that advanced generative models can move beyond research demos and into real-world deployment.